Okay, we're going to start by looking at this first problem here in the corner, which asks us to find the log base 7 of the quantity 25 minus x equal to 3. So the first thing we're going to do is exponentiate both sides using the base of the log, which is a base of 7. And that, by the inverse property, brings down the 25 minus x, the argument of the log, and then that is equal to 7 to the third power, which is 343. Okay, then to get the x by itself, we're going to subtract 25 from both sides, and then negative x is equal to 318, and then we'll divide both sides by -1, and x is equal to negative 318. And then next we'll look at the second problem, where we're taking the log base 4 of the quantity x minus 6, and that's equal to 4. So we'll start by exponentiating both sides, and by the inverse property, then x minus 6 is equal to 4 to the 4th power. It looks like in your work here you tried to multiply 4 times 4. That's not the same as 4 to the 4th power. 4 to the 4th power is 256, not 16. Okay, then we're going to add 6 to both sides to get x by itself, and that gives us 262 as our answer. Okay, so next we'll take a look at this problem. And the original problem was 4 natural log of x minus 3 is equal to 7. And it looks like you tried to divide both sides by 4, but you can't do that without also dividing the -3 by 4. So instead, we're going to add 3 to both sides, and then 4 natural log of x is equal to 10. And then we can divide through by 4, and the natural log of x is equal to 5 halves. Okay, now we can exponentiate both sides with the base of the log. Since it's a natural log, that's base e, and the inverse property then brings down the argument of the log, and x is equal to e to the 5 halves power. We're asked to find an approximation to 4 decimal places, so we'll enter e raised to the 5 halves power and round that result to 4 decimals. So 12.1825, since the 5th decimal is a 9, we round the 4 up. So that'll be 12.1825. Okay, next we're looking at, let's see, I'm not 100% sure where this problem is existing here. I guess this is it. So if we look at the original, that's a log base 7 of the quantity 2x minus 7 equal to +2. And we're going to exponentiate both sides with the base of the log, which is a base of 7. And that brings down the argument of the log by the inverse property, and 7 squared is equal to 49. Okay, looking at your work up here, you ended up with a -5, so not sure how exactly. Maybe you tried to subtract 7 instead of exponentiating with a base of 7, but you should have had 7 squared there, which would be 49. Okay, then we're going to add 7 to both sides, and 2x is equal to 56. Then we'll divide both sides by 2 to get x equals 28. Okay, so then we'll take a look at this problem, and the original problem was 6 minus the common log of the quantity 8x equal to 2. And if we subtract 6 from both sides, then negative log of 8x is equal to -4, and we'll divide both sides by -1, and the common log of 8x is equal to +4. So one of the problems I see in your work here is I'm not sure where that negative came from. This should just be a common log of 8x equals 4. You also cannot undo a logarithm with division. The log would not just disappear. So to undo a common log, you exponentiate both sides with a base of 10. And then by the inverse property, 8x is equal to 10 to the 4th power, which would be 10,000. Then we'll divide both sides by 8. And 10,000 divided by 8 is 1,250. Okay, that will bring us to this problem, which is a log base 9 of the quantity x minus 8 equal to 2. And again, it looks like you tried to subtract 9 from both sides and ended up with this -7, but that's not how you undo a log. The inverse of a log is an exponential. So in order to get the argument of this log removed from the log expression, you have to exponentiate both sides with the base of the log. So 9 raised to the log base 9 of the quantity x minus 8 then is x minus 8 by the inverse property, and 9 squared is equal to 81, right? So this would not be a -7. Then we're going to add 8 to both sides to get x by itself, and x is equal to 89. And then the last problem, we have a log base 8 of the quantity x plus 4 equals 2. And we're going to exponentiate both sides with a base of 8. And x plus 4 then is equal to 8 squared, which is 64, not 16. Right here, the 16 would come from multiplying 8 times 2. That's not what we're doing. We're taking the base, which was 8, and raising it to a power of 2. That's what it means to exponentiate. Okay, then we can subtract 4 from both sides to get x by itself, and x then is equal to 60.